So in this problem, pure carbon is burnt in a furnace supplying 20% excess air, 80% of the carbon in the fuel goes to CO2, the rest to CO. Determine the composition of the combustion gases. So we have here our image or a figure in this problem. We have here the furnace, and we have a pure carbon which is 100% and an air which have an excess of 20%. And we have to determine the composition of the combustion gases or the flue gas. So first thing to do is to have a basis. Since we have a solid fuel here which is the pure carbon, our basis becomes 100 gram pure carbon. Then next we have to solve for the number of moles of our carbon. So number of moles of our carbon is equal to 100 gram of carbon multiplied by 1 gram mole of carbon over 12 gram of carbon. So this 12 gram of carbon is the molecular weight. So the answer is 8.32 gram mole of carbon. So since we have 1:1, our theoretical O2 also becomes 8.33 gram mole of O2. Next, we have to solve for the supplied O2. So we have here in our problem, we have 20% of excess air. So for our O2, we have to add this 20% of excess air. So 8.33 gram mole O2 plus 0.2 multiplied by 8.33 gram mole of O2. So we factored out the 8.33, that's why we have 1 here. So 8.33 gram mole of O2 multiplied by 1 plus O2. So we have here 10 gram mole of O2. So this is the supplied O2. So here we have the flue gas, which is we have to determine its composition. So we have a carbon. Then in our problem, we have 80% goes to CO2 and the 20% goes to CO. So in here we have an actual combustion. So in our actual combustion, we have the carbon. So since our carbon is 80%, so the molar or the number of moles of our carbon, which is 8.33, multiplied by the 80%, which is the 0.8. So the answer of this is 6.664. Since we have 1:1, so our O2 also becomes 6.664 and our CO2 also becomes 6.664. Next is we have to solve or to know the actual combustion of the CO. Since we have 20% excess of CO, so our carbon here will become the number of moles, which is 8.33 multiplied by 0.2, which is the 20%. So since we have also 1:1, our CO2 also becomes 1.6666. And we have here our O2. So we have to, the value of CO2, we have to divide it by 2 to get the O2. So we have 0.833 of O2. So from the previous solving, we have supplied O2 of 10 gram mole. So since we have excess, we have now to solve for the unused O2. So here, we add 6.664 O2 and 0.83 O2 to determine the used O2. So 6.664 plus 0.833, we get 7.497 gram mole of O2. So we have to identify or determine the unused O2. So to determine it, we have to get the supplied O2 of 10, then minus the used O2 of 7.497. So we get the unused O2 of 2.5 gram mole. So we're plugging it in our fuel gas here. Next is to find for the supplied air. So we will use the supplied O2 to solve for supplied air. So 10 gram mole of O2 multiplied by 0.21 gram mole of O2 in every 1 gram mole of air. So cancelling out the gram mole of O2, we have 47.62 gram mole of air. So next, we have to solve for the supplied N2, and we will use this supplied air. So 47.62 gram mole of air multiplied by 0.79 gram mole of N2 in every 1 gram mole of air. Cancelling this gram mole of air, we have 37.62 gram mole of N2. So now we have to plug in it in our combustion or in our fuel gas area. So we have for CO2 6.664 gram mole. For our CO we have 1.666 gram mole, and for our N2 we have 37.62 gram mole, and for our O2 we have 2.5 gram mole. And we add this all, we get 48.454. Since we have to determine the composition of the combustion gases, we will divide these values by 48.454 gram mole. So for CO2, 6.664 gram mole divided by 48.454 gram mole times 100, so we get 13.75%. For our CO, we have 1.666 gram mole divided by 48.454 gram mole times 100, so we get 3.45%. For our N2, we have 37.62 gram mole divided by 48.454 gram mole multiplied by 100, we get 77.6%. And for our O2, we have 2.5 gram mole, so this is divided by 48.454 gram mole multiplied by 100, we get 5.16%. So this is now the composition of combustion gases. We have for CO2 of 13.75%, for CO of 3.45%, for N2 of 77.6%, and for O2 we have 5.16%. So these are all the answer.